Okay, so this is OpenTelemetry, the universal observability umbrella. And I'll take a moment to introduce myself. I'm Abhinav Kapoor. I'm technical architect and programmer for .NET Solutions at Nagarro. And for me, important is that we use observability to keep the critical line of business applications running. So within this um, talk, you would find that it's done from a little bit of a programmer's mindset. However, I do understand that there would be people who are not programmer and who come from more of a DevOps background. It's more of conceptual, and then we'll go to a demo. I think it should be well-rounded. Before we move on, may I just know how many of you are, let's say, DevOps background? All right. And I'm assuming the others would be from the development background. Great. Okay, so what we're gonna cover is, as I already know, that there are 50% of people who are on the beginner level, and then there are some who are working, and so I will go ahead with the concepts first. That's the first part of the talk. The second is we'll go into the open telemetry, and third we will see some demo. So let's get started. How many of you recognize him? Great. So yeah, he's Sir Lewis Hamilton, 7 times Formula One champion. And I was watching a video of his, and he was saying that they get a lot of details about the car while they are driving. So that's basically a photograph of his steering wheel. And they can really control the drag. They can control which tire needs what kind of braking, and not just that, even the teams which are in the in the pit stop, they are also getting the inputs from the car, and they are talking to him on some sort of a communication channel and giving him instructions that he can't see on that little screen that he has. So the point is, when you have complicated systems and the stakes are high, you do need something wherein a machine is able to tell its internal state to the outside world. Yeah. Why did I think about this kind of an analogy with Formula One? Because Formula One and modern software, it does have some sort of parallels. Yeah. Both are complicated, a lot of moving parts. The second is that the stakes are high. Maybe the business reputation is on stake, could be, or maybe it's a critical line of business application. We are using cutting edge technologies, and so there are more things that could probably go wrong. That's another thing. We need fast reaction. And another thing is that there are a lot of teams working, and they come from different backgrounds. So we have to have some sort of a common view of the whole system running and winning. So basically, observability, if we have to define, observability is the property of a system to convey its internal state to the outside world. Yeah? In terms of software, we could also consider it as a non-functional requirement. And this is such a non-functional requirement that can help you measure other non-functional requirements. For example, if you say 99% of my requests must be done in, let's say, 300 microseconds, how do you prove that? You need some sort of an observability there. So now that we have defined what is observability, let's see why do we need observability. So we want to avoid reactions like this. Yeah, we don't want to come to office and see that last night our systems did not work. So if you see this is surprise, shock, and panic. Yeah, and this is what we want to avoid. So how do we do that? I will read it out. So basically, let's see what happens in production when there is an issue, an incident that we have to fix. So this on the lower side is the lifetime. That's the start of the issue. Let's try to zoom in. So that's the start of the issue, and that's the end of the issue. And within this, what happens is you have to detect the issue to begin with. You have to identify the issue, fix it, and deploy it. Now, this is what happens. You have a mean time to detect. In a lot of projects, this is a key performance area. Mean time to detect, mean time to identify, and mean time to resolve. Now, if how does observability help here? The point is, if you have some sort of matrices, now matrices, we'll come to it in a moment, but think of it as numbers. Yeah. So if you have numbers going up and down, you could detect some sort of an abnormal behavior, probably scale up or do something else. But this would help over here in the detection much before the rest of the world detects it. There is also a concept of synthetic requests, which also helps in detection, early detection. Identifying is where traces help, and we will come to traces also, but just know that this is some sort of, how the flow is going across the systems. And then it is basically resolution and deployment. So resolution can also be shortened if we have, a good logging. Of course, deployment is out of scope for this, but all the other three are. So now what has actually happened and why are we now talking about it and why is it more critical now than what it was 15 years ago here? The thing is that the technology is changing. There has been a rise of microservice architectures. And with microservices, what has happened is that they have taken out the complexity from the software because now the code base is smaller. However, the complexity goes much more in the, in the connections. So there are a lot more moving parts and therefore you have to take care of the moving parts. It's not as straightforward as this big one monolithic that was used to exist. So one of the definitions of complexity is, which I like, is when the dependencies among the elements start to matter, and in a microservice, the connections between the services start to matter. So that's why we need it. There are also some more trends that have happened, and that is microservice. We have already covered. The other thing is that it's not just one kind of application. There are many applications. So it's a polyglot environment that we are dealing with. And the other one is the ephemeral nature of cloud. So we can't have files and go there and see because maybe the pod is actually destroyed by the time we go and see. So these are the things that have actually pushed for a more modern kind of observability. So how does it actually fit into a cloud native landscape? We will first of all take a look at the conceptual view and then we will go into a more physical view. Yeah. So conceptually, there is the instrumentation part. This is when it is actually being generated. So you're generating signals or then you're capturing the signals, then it's being transported. And after it's transported to a backend, it is analyzed and then acted upon. What we need over here is we need some sort of an agent or SDK which can do this. And if it is an agent, it could probably send it to an endpoint. So it's the agent's job to send it back. Or the other pattern that is used is a scrapping. So you expose a meta endpoint, and within that meta endpoint, there is a scrapping that is happening. Once it's there, the dashboards can be used to view it and alerts or notifications to basically act upon it. So this is the conceptual view. And now let's see how does it fit together. So this is the thing. The business problems are solved by applications, and the applications are sitting at the topmost layer over here. Below them is a lot of infrastructure that can actually go wrong. You have orchestrators. By the way, just a question: Is it helpful if I zoom, or is it better if I don't zoom? Is it distracting, or is it's better without zoom? Okay, pretty fine. Then I'll continue without zoom. So if you see, I've just taken some examples. For example, there could be a certificate manager, IAM, some resources like DB, managed DB, or so on. And on all top of this, our applications are sitting and working for business. Now, if any of these lower layers go wrong, the application won't work and the business would get suffered. And that's why we need to have a consolidated view to quickly identify where the problem has gone wrong. And that's why usually all of them, they are transferring the data to some sort of a backend aggregation. And then from that aggregation, it is transferred to some sort of a dashboard where it could be monitored and acted upon. Another thing to consider here is that usually there is an access control in place, which could be regulated legally also. And I will come to those things also a little bit. We'll just touch upon such aspects also. So essentially, this is how it would be in physical space here. Now let's just go a little deep into the application instrumentation. This is the kind of background that I work with as a programmer, and I will try to keep it a little high level, and we will see what are the pillars for application observability. So one of them is no problem. Okay, so so there are essentially three pillars. I've put four on this slide, and the fourth one is also getting cut, so which is not too bad. The first one is logs. Logs basically tell what happened and who did it, some sort of important things that you would like to, keep track. Traces are how did it happen? How was the system talking to another system, and how are the use cases flowing across the systems? Then you have matrices, and matrices tell how much happens. These are basically numbers, which you could query or, we'll see them later. And you can have alerts and SLOs, service level objectives, that you can form on these things. Moving on, what we actually want to do is there is some sort of an auto instrumentation that is available, and there is some sort of a manual instrumentation. So auto instrumentation basically means that you have some agent which is sitting there and automatically capturing all the data. It's a great place to start if there is really nothing. But if you want to be more precise, you have to go to the next level, which is manual instrumentation, and be more intentional. So the thing is that with infrastructure, we get a lot of signals out, but the intention is to not have just connected black boxes, but really to open up the applications, and that the applications can really trigger, can really, give these kind of signals out. Logs, matrices. Health check is not considered a pillar, but health check is important because it helps you to see if you want to restart the pod or if you want to divert the pod. And so therefore, there is another meta endpoint, for example, which is called health, which can be exposed. Another thing from my point of view is it also speeds up the development. So if you have nice points, there are certain bugs that you think can happen, or you think they cannot happen, but you can figure them out much earlier. So it's also better from that point of view. Now we come to logs, the most obvious. Everybody would have written logs. So what can I really tell about logs, right? I could tell you how the new logs are working or how the structured log works. Typically, this is how it is. It starts with the application producing logs. There is an SDK. All the modern applications have a similar kind of thing where you can simply configure and add more appenders. It's a configuration change. Behind that, what happens is there is something called as log providers, where they are going. And there are several log providers that one could use. And usually they are structured logs. And the benefit of structured log I will show in the demo, and I will also have a slide after this. So the type of log, there will be two types of log. If we talk about technical logs and business logs, technical logs basically mean that they are, application not starting or which port the application has started, but it doesn't have things like user data. It doesn't have, for example, if someone of you is working with European customers, you would know that there is a GDPR and you can't really put it on the terminal. There are strict regulations. It has to be directly sent to the main logging journal. And this is one thing, one kind of distinction that we can make. The other one is based on if it is structured or unstructured. Structured basically means that you pass some additional parameters, and they work very well. How? We will see this over here. Here I will zoom a little because this is from Elastic, Elastic Observability. And if you see these, this is some sort of a demo I prepared, wherein you have a weather forecast service, and it just says generating 5 forecasts. Now, what I've done in the query is it is a pretty readable, human readable log, right? And if you look at it, the query at the top, it's done like a SQL. So it has both. It is a human readable log. At the same time, it has the numbers to query it and to aggregate it. This is called the duality of the logs because they are readable as well as queryable based on the matrices. Moving on, how did it happen? This is basically what is covered by trace. So some of you may know that there was something called as tracing in the older applications where you would simply say enter this function, enter that function. This is still there, and OpenTelemetry and traces take it to a next level. We will see that in the demo. The other thing is distributed tracing because we also want to see how the calls are flowing across the systems. There is concept of baggage. This is not something new. This has come from W3C. And this basically means that you can really pass on the state, serialize and deserialize the state. And that's how you are basically passing on the stages between the processes. So it's the out of process if it has to be transferred. And we'll cover that. So right now we are just running through the concepts. This is what it is. This is what it means that you have, you have a trace collector, and it is constantly getting the traces from the entire use case that is following. And usually there are IDs which are used to then stitch it together and then give a nice view of what happened where. We will also move on now to the next one. How much is happening? This is matrices. It follows quite a similar pattern like the logs. There is an SDK which produces matrices. This is the meta endpoint, and a tool like Prometheus would scrap it. There is also a pattern where you can send it, but mostly, there is this scrapping endpoint, and then it could be visualized and alerts could be generated on top of it. There are a lot of type of, matrices, essentially 4. One of them has been deprecated in OpenTelemetry. It depends what we are looking for. So there are counters which are simply incremental. So they are helpful for some business kind of rules. So if for example you want to see which product is selling the maximum, you can have reports, sure, but you could also do it from this. And there is a little bit of example. They are called dimensions. One thing I've learned is that you do not put a lot of dimensions because then I think we will also cover it in Prometheus at scale probably. That if you put a lot of dimensions, it just kills it. So yeah, let's move on now. Then we have gauges. They are simply point in time, something like queue size, CPU. These are the second thing. The third is histograms. These are buckets. So you can, if you want to see how much 99% of my requests are coming into, 400 microseconds and so on, something like this could be used. There is this summaries. This is slightly different because in the previous ones, every calculation that was happening, the applications were simply sending the numbers. Yeah, the aggregation was happening at the back end. This is different because here the aggregation happens at the application level. This means that it will slow down the application more. However, the only possible use case for this is if you have very strict KPIs where you don't want to, you don't want an approximation, you really need the exact numbers. So that could be the only thing. However, it is of limited use and OpenTelemetry has already marked it legacy. Another thing is you can't really rejoin in the last one because it's already mixed together as it is produced by the application. So now this is the last thing on the matrices. What can you do about it? You can generate some alerts. This is, for example, a screenshot from OpenShift. You can create alerts, or you can create some nice views, for humans to see what's going on. How is the system doing? This is the health check, usually not considered part of the pillars, but it's still relevant because maybe you have to restart the pods and there are a lot of things you can check out of box because the SDKs are there. So moving on, any questions so far, or we can take the questions at the end also. So I'll just recap if there are no questions. What we have covered so far. We have covered the basic concepts, why we need OpenTelemetry, and sorry, not OpenTelemetry, why we need observability at first place. And the second thing we have covered is what are the 3 pillars of observability. And now we are going to go to OpenTelemetry. So what is OpenTelemetry? I think this was a warm-up question also in the beginning. We address it now. It's basically an open source observability framework, and it is meant for both infrastructure as well as applications. Um, it's a protocol at heart, which aims to be vendor agnostic. OpenTelemetry produces SDKs, and there is also community support, which is quite strong. So it's not concerned with the backends. So for example, if you have been using Prometheus or Jaeger, that falls out of the OpenTelemetry. It is responsible for creating of these signals, collecting these signals, and transferring it to the backends. These are the three things it is responsible for. If we talk about the three signals, and now the terminology changes, it's not called the observability pillars, they are called the signals over here. The signals are basically, there are three signals that it supports. The first one was traces. That's the reason I did not cover traces earlier, because there it really shines out. That was in 2022. Then matrices were added, traces in 2020, matrices in 2022, and logs, because already so much was done on logs, this was not the priority. Logs have been added last year, 2023. So now let's just see what was happening before this. I think this was also something which was a question, what was happening before, and so we can see what was happening before. Before that, there were a lot of vendors with their own grammar. By grammar, I mean their own SDK. You had to use their own style of coding, and there was basically a vendor lock-in. So yeah, oops. So Dynatrace is almost 20 years old now. Dynatrace started in 2005, followed by AppDynamics, New Relic, Datadog in 2010, then Prometheus came up in 2012. This is a chronology of how things happened in this space of observability. Then we have this open tracing, which was somewhere in 2007, 16, and with that then followed by Jaeger. And in 2019, there was one thing significant that happened, which was the merger of open tracing and open census, into OpenTelemetry. 2020, we get the first one, beta of the traces. So before this, there were vendors, they had their own SDKs, and there was a problem of vendor locking. You couldn't really move from one to another. So you were married to a particular vendor. And this is exactly what OpenTelemetry tries to avoid. We will see that in the demo. Now, what are the components of OpenTelemetry? We begin with an application. The application has an SDK or an agent, depends what we are using. This is the first thing. The other important thing is the backend. We have to store it somewhere, so there has to be a backend. The third thing is the protocol, which is also defined in OpenTelemetry. And the fourth thing is optional. It depends, collectors. Do you want it? Do you not want it? It is recommended that you use it, because any kind of retries to the backend, this component can do it. Otherwise, it's up to the applications to do it, or the SDK to do it. So if you want to relieve the applications of this thing, you use a collector. The collector is also necessary if you're doing some sort of a migration from source that is not OpenTelemetry compliant to something which is OpenTelemetry compliant. So some things like that, if you want to do, it has three things, a receiver, exporter, and processor. And that's where, one has to work on depending upon if it's a migration use case or not. Moving on, this is then another image. I took it from their official, from an official one, but it's pretty much the same. Over here, you see microservices, which is the business, the business where the business sits, business logic sits. You have the infrastructure and some other managed APIs and databases, and they are all sending it to the collector. And then the collector is basically sending it to a backend. So this is how OpenTelemetry in general is, or how this fits together. Now let's start from the traces part. Now the traces is the place where it shines out the maximum. Let's look at a use case here. So we have to read a front end. There is a front end, and we want to read a news. And then there is the comment section, and there is an advertisement section. So there is news, comments, and advertisement. Yeah? These are the three things. Now, if you see here, this is the big thing being done. Yeah, the news is the big thing being done. In this big thing, there are several small things that have to be done. The small things being read the comments, read the advertisement, read the newsletter. So this is, just know, the big thing is called the trace, and these small things that we are doing, these are called spans. Now these small things may be in process, which means that the same service is doing one function calling another function, or it may be out of process, which means that one service is calling another service. And we will see both of them also in the demo. But if we see here, as per this use case, so the blue thing represents this service, and you can see that there is a trace. This is the trace, the whole thing is a trace. And these are spans, these blue lines, and then each yellow line is a span. This is the smaller thing being done. And so basically trace is a container of spans. Now, what is span? Span conceptually is some sort of a time-bounded work. It is kind of a transaction, or so if you look at the trace, it is like the complete use case, and then within that one scoped work, you will call it as trace. Span. From the technical point of view, it's a structured data. It does have a unique ID. It's called span ID. It has a code. Everybody would have worked with correlation IDs, I'm assuming. Correlation IDs are basically used to stitch things together or stitch the logs together if you are having a lot of logs across a lot of services. And this has a correlation ID which is called the trace ID. It also has something unique which is called the causality idea. Why does this span exist at first place? This defines the parent-child relationship between the spans. And what you can also do is you can also, for example, if there are exceptions happening within a workflow, so because this is defining a workflow, you could generate events, and depending upon the visualization tool being used, Elastic, for example, does support it. Depending upon the visualization tool, you would really see a red mark at that particular time when the error happened. So these are, this is supported by the events. Yeah. Then another thing is you can also have related spans. They are not really parent-child, so it's not a strong parent-child relationship, but this is some sort of a link between the spans, something like a batch. The problem, what happens is, if you have a parent-child relationship, your span can grow very deep in the hierarchy. Yeah? This can happen. So usually when you get a span in your new function, for example, you have two possibilities. You could either create a new span out of it, or you can enrich the span with more context. If you do that, your spans are more wider rather than deeper. And this is somewhat considered nice in certain cases, let's say. What I would also like to show is, yeah, this is just a, conceptual view. It has a name. Every span has a name, start time and end time, parent span, and so on, things that I just explained. So moving on, you could have spans in process or out of process. And this diagram over here is basically showing both of them. This is, I tried, it's like a little microservice architecture, one service calling another and calling another. And so you can see all of them together, at which time point what happens within the service as well as outside the service. It's all kept together. If you have exactly what I said, deep versus wide spans. Now matrices and logs, we have already covered them in the previous one. There is not much to add except for the fact that they are linked to the traces. Once they are linked to the traces, it's very easy to switch between the two. So this is a log, and every log will actually have a some sort of a trace ID so that it can be linked to the trace. Now let's move on to the demo. I think I went pretty fast, but I'm really slow in the demo. Yep. Yes.
Memory leaks.
That's a good point. Depends on the language which you are using. Usually in .NET you have two possibilities of creating these I think you're talking about creating the activity source. Usually there are two possibilities. You can either do a dependency injection or you can have static. I personally like to have static because it's creating less of a problem for me. But if you are talking about specifically about memory leaks, there is another tool. It is in .NET.
And for example, if you move to say Go in Python, how do you, is this like, I,
I'm sorry, I can't.
hello?
Yeah, now
it's hard to trace out when I'm working with Go and Python. Sometimes there's a memory leak, and when I go to trace it, it's after I trace it just stops. There is no logs beyond that, so it's hard to figure out where to go beyond that. Instead of going to the like ICNC where it is.
So to be honest, as far as the memory leaks are concerned, are you asking if traces could be used to detect memory leaks? Okay, not in my view, no. Or at least not in my experience. I would use more or less traces to quickly figure out where the problem is and how is the flow actually going. For memory leak, at least in .NET, there is another tool that really tells you, that does a lot of things and tells where it could be, but it is all run locally. See the setup. And so yeah, let's then start. Sorry, any other question? Okay. So just to give a little bit of overview, the demo was done like a no, not three, four microservices. There was, and because we were talking about monsoon and clouds and umbrellas, I thought let's do a little bit of weather thing. So there is a local weather service. Um, I think I skipped one slide where it was described how it was done, but I can explain it. So there is a local weather controller. This calls the national weather controller, and then there is a global weather forecaster. Yeah, the global weather forecaster is receiving some sort of messages from Kafka, from a satellite broadcasting, and this has been modeled like a Kafka producer and a Kafka consumer. Yeah. So in totality, four services. And let's just begin the demo. So this is basically my setup. Set step back a bit so that I'm not obstructing. So just to show, what I will be showing here is there will be two backends that I will switch. One would be a very light Aspire dashboard, and the other one would be heavyweight production grade Elastic. Yeah. So yeah, this is, I'm trying to figure out which window, but this is one backend Aspire dashboard, a very lightweight, and this is the other one, which is production grade Elastic. Okay? And now this is the thing that I already explained. This is the microservice architecture, about four of the services, and now I'm just trying to bring them up. So I could also maybe speed it up a little. Yeah, so just brought up all the services, and as soon as the services have come up, it's now generating, Kafka producer is generating the cases, and we see that on this we start to get the traces. Yeah, and now we can't see it very clearly, but there is also some sort of details that we can see. On the right side, there is a link, and if we go to the links, this is now the structured log. So basically, within this simple Aspire dashboard, we get three things: structured logs, traces, and matrices. And right now, it's the structured logs where we are really seeing. Maybe I need the zoom thing. So here we can see the logs, and what we can also see is that how is each log linked to a trace. Typically, when we are doing a production issue, we would go the other way around. We would go to the trace, and from the trace come to the logs, because otherwise it's really hard to find it. All of these are structured logs, and their benefit we will see it in the next slide when we go to a more not slide but next sections when we go to a more production grade elastic. So moving on, uh, this is an in process thing, and I could probably uh, show what it means, what is being done here. So basically, it has got a message from the satellite. So it's a satellite consumer. The first step, it has to decode it and save it. And this is what you see. This is all the functions, one function being called after another, and each of them is generating its own trace. And that's what you can see. And you can also see the time. Oh, sorry. This is just some sort of metadata that I wanted to show, which is, I think that there is a span ID, what we have already spoken about, a name, and then we can we can toggle between the two. I will skip a little in interest of time. And now what I do is I do across the services call. So from the local all the way to global, covering national. So then we will see them. So now you see that there are traces being generated over here. And if we go to our detail of any trace, we would really see the similar kind of out of process design that we were seeing earlier. Which service, what is the operation, and how much time did it take? So yeah, these are out of process traces. And now, I think beyond this point, what I did was just to make a switch in the configuration. So just to switch, and that's the beauty of the OpenTelemetry, that you can really switch the backend. So far, it was a lightweight Aspire dashboard running over here. And it's now, now it's the matrices part. Let's just talk about the matrices also a little. I have selected the, so I selected one of the services, and then I can see its matrices, some sort of graphs of how many messages are being transferred and so on. We could do some query expressions on this. But from the demo point of view, I would move on to the next slide, next section, which is more important, because now I have changed the backend. So the only thing was needed was switch it to Elastic, give it the credentials, and now I could go back from this one to the Elastic, but doesn't happen. Yeah, now it happens. So now same services are talking to a different backend, and just changing the time over here. So to bring it into the monitoring window. This is the overview, but I will soon move to the APM part of it, which is over here. So now we see traces, and the traces are basically the name, the use case. So there is just two use cases that were happening at this time. There was a broadcast of satellite data, and then there was a receiving of the satellite data. And we see only these two use cases and the two services. So the satellite service and the broadcast service is running. Now, once we go inside, we see more details about it. And at the bottom, I think I will come to the bottom in a moment, where I would be talking about the traces and the logs. So everything is connected together. You could see the logs here. And now this is the little demo I wanted to give about trying to find a log which looks very human readable, updating so warm temperature. And now what I can do is I can write a query to say how many entries are there which are below zero, and I will get a filtered result as per that. And this all happens because of the structured log, and now we will see a structured log also. So this is what a structured log looks like. It has, yeah, it's a little hard to, but it doesn't. It has a complete message, but it also has a well-formatted string and and all the fields, and that's what you can query. So we'll then move on from this one. And now looking at the tracing. So let's go to the tracing. What's there with the tracing? Yeah, this is now the across the services out of process tracing that is happening. Okay, so that's all. I think I've taken a lot of time, and I think this was it. Was there anything important to show? No, nothing. This is just the out of process tracing that's happening at the end. And just one last bit I will cover, which is the action part of it, because Elastic also gives that, and that's what is needed. Usually, you could define certain rules, yeah, what you want to do when certain things fail, and you can define those things over here, and then you can take an action at the when those conditions are met. So that's pretty much it. And yeah, this can continue, but I think there is nothing new. So thank you everyone. If there is a question, we could discuss now or later.